thank you for being here today. I'm Lisa Barreau, the Vice President for Research here at Utah State University, and I want to welcome you to the Wynne Thorne Lecture, which is part of our USU Research Week, where our goal is to highlight our faculty, graduate students, and undergraduates who engage in research, scholarship, and creative activities. We're past the halfway point this week, having already had our faculty author exhibition in this very same spot on Monday. Yesterday, I hope many of you were able to attend the Student Research Symposium, which was held here in the library or online. We are also happy that you could join us here this afternoon. To tell you a little bit about the origin of this award. Named after USU's first Vice President for Research, the Wynne Thorne Career Research Award is a long tradition and a very special honor at Utah State University. Each year since 1979, USU has selected one outstanding faculty member to receive this highest research recognition. Awardees are selected for their decades of significant quality research. They are individuals who are known nationally and internationally. I believe, looking around our audience, that we have several previous Wynne Thorne recipients, and I'd like to just ask them to raise their hand as I call them out. And so, Joyce Kincaid, the 2018 recipient. Bruce Bugby, 2016. Alvin Henge, 2015. John Neely, 2013. I think I got all who are in attendance. Good. We honor our Wynne Thorne awardees, and then we turn around and we ask them to give a lecture about their research story at the following year of their award. We are especially excited about this event, which is our first Wynne Thorne lecture since 2019. We want to give a special acknowledgement to Professors Chuck Hawkins and Greg Madden, who were the Wynne Thorne recipients in 2019 and 2020, who were not able to deliver an in-person lecture due to the pandemic. We remain grateful for their contributions to the university and sorry that the conditions could not permit us to have that in-person lecture that they deserved. The 2022 awardee this year, our new awardee recently named, is Dr. Melanie Dominique Rodriguez, a professor in the Department of Psychology. We'll hear from Dr. Rodriguez next year. Today, however, we're going to hear from the 2021 Wynne Thorne Career Research Awardee, Dr. Ron Sims from the Department of Biological Engineering in our College of Engineering. His dean, Jagath Kalarachi, will introduce Ron, but first we'd like to take a moment to show you a short video showcasing Ron Sims and his outstanding work in the Department of Biological Engineering.
We need a more comprehensive, more inclusive vision to make sustainability real. And so what we're doing in this organization that I started over a decade ago called Sustainable Waste to Bioproducts Engineering Center is to train students so that they have the tools and methods to design, build, and test sustainable technologies. And the whole idea was to look at waste as a resource out of place. That's our whole mantra. What we do is we design, build, and test biological reactors using the smallest of living organisms. We use bacteria and algae. When you team them up, they can do mighty things. And so coming to Utah State, they encouraged. What Utah State said was, go for it. Create your own future. The nice thing about Utah State when I came here is that basically the administration said, Ron, whatever you want to do, go prove you can be successful. The 40 years have been an incredible experience because I've been able to create something that is impactful for society. Not for me, but it helps society, and it helps train these new students who have to get out, these new engineers, and build a sustainable world.
Thank you, Lisa, for that short introduction on the award. So it is my, so those who are not familiar with me, I'm Jagat Kaluwara, Dean of Engineering at Utah State University. So I got a script here because I just didn't want to miss anything about Ron's achievements over the past so many years. So once again, it's my pleasure and privilege to introduce an accomplished faculty member like Professor Ron Sims from the College of Engineering. Now, I have known Ron for a long time, and he started his career at civil and environmental engineering over the years. Now, over the past few decades, he has been tremendously successful in all areas of our land grant mission. In research, I would define Ron's field of research as biology-driven engineering, focused on protecting public health and the environment. As a researcher, he has been recognized with many awards at USU and elsewhere. To name a few, he was the recipient of the Governor's Medal of Honor for Science and Technology, the president of the Institute of Biological Engineering in 2015. He's a fellow of the American Institute of Medical and Biological Engineering and a fellow of the Institute of Biological Engineering. His other research accomplishments include 265 publications with more than 8,000 Google citations and with an H-index of 44. Ron has been awarded more than $17 million of external funding over the last few decades. He is an excellent graduate advisor and has advised 19 PhD students and 38 master students. In any given year, now this is a fact, I have seen this over and over again, he would mentor 60 to 80 undergraduate students on various projects, including capstone design, as well as undergraduate research projects. After 40 years of service, believe it or not, he still had the time and energy to write research proposals. And in 2021, he was awarded $2.4 million from DOE as the PI. So that talks volumes about his research interest and passion in this area. So Ron's service and leadership roles are equally impressive. Again, just to name a few, he was the president of the Institute of Biological Engineering from 2003 to 2014, program chair, International Algae and Algae Biomass Organization. In 2017, NATO Organizing Committee on Land Treatment of Waste. Here at USU, he was the founding department head of biological engineering, director of the Utah Water Research Lab from 1996 to 2003, and co-director of Sustainable Waste to Bioprocessing Engineering Center from 2010 to the present. In addition, he is serving or has served in many local, regional, and state organizations, providing his expertise and services to especially to the city of Logan and the State Water Quality Board. The college and the university built a new facility at the Woodridge property close to the water lab, in case if you are not familiar with the area, to a lab facility to enhance. It's called the app, I can't remember the acronym, algae something. That's a nice facility, and we are opening it on the 20th, and all are welcome to attend. That's next week. And on a personal side, he's married to Judith Sims, who is the director of the Utah On-Site Wastewater Treatment Training Center and faculty at the Utah Water Research Lab. Now, I cannot end this introduction without mentioning that he is also highly sought after and recognized well-known Aikido instructor. Okay, and he teaches a class in the physical education program. Now, all that in addition to all his teaching, undergraduate and graduate teaching in the biological engineering program. Again, Ron, it's a pleasure to have a faculty member like you in the College of Engineering. And congratulations once again. Thank you.
Thank you very much. All right, thank you. Thank you. I'm going to move away from this because I'm going to maybe overwhelm here. Let's see, can you all hear me in the back? I got this one on. Okay. Is it too much interference here? Do we need help from, okay, you guys are all right? Okay, so thanks. 1, thank you very much for showing up. 2, our theme is going to be energy. All right, and 3, the energy I'm going to talk about comes from the students. So in 40 years, the idea was you either fight the energy and try to subdue the energy, or you use the energy. So what I'm working on is using the energy.
Ron, move
Yep.
that mic back a few feet, just the whole stay out.
Gotcha. Let's see, Anna, because I don't need, I'm going to wander around, which is why I'm wearing this lapel.
Ron, if you want to kind of stay a
Oh,
little
and
bit
I should
behind
stay?
the line of sight of the speakers,
Sorry.
that will do it for you.
Okay, will do. Okay, that's good. See, we can modify behavior. We can learn even after 40 years of working here. It's possible to do that. Let's see. So I can operate the slides from here, right?
There's a clicker right there.
Okay, gotcha. So here, what we're going to do, what I'm going to work with you on is looking at some themes here. Industrial development. We're going to talk about industry. And I've been involved in several different industries that have actually impacted me in the way I behave today. The other thing is in terms of the person, this person you see talking to you has been influenced by people, and that's the people have been my previous bosses, previous people that I have worked with that have influenced me, teachers, students. So the idea is you are a composite of everything you've been through, what you say to people, what they say to you, how people interact with you. And the idea that I've learned over 40 years is to be open, to be open. Oftentimes as we proceed on in life, we get more restricted. The idea is to try to stay open, and with that, you stay more youthful, and you also are able to take in energy of others. You don't hurt their energy, but you team up with them. So we're going to talk about that. So industrial development, I'm a big industry advocate. I'm a huge industry advocate, so we're going to talk about that. And then also for design, a context for design. In engineering, I'm in charge of the capstone design kind of series of 3 courses. I want to talk about design with industry input, okay? Connecting the students with the real world. And then what I particularly want to do is focus on environmental and public health context. The environment and public health. And what I'm going to do here is saying we're coming to what's called, we're trying, aspirational, is the circular economy. Okay? So what I'm saying here is we're trying to build towards the circular economy aspiration through the students by collaborating and partnering with industry. Make sense? Are we okay? All right, so let's see here for the next slide. Whoop. All right, moving forward. Forward. Okay, Anna. Oh, let's see. Here we go. Let's try this. Oh, I've got the wrong clicker. So, you know, isn't this perfect? Isn't this perfect? Yeah. This is, see, I'm keeping you awake, if anything, right? Right? Gonna keep you on your toes, right? Thank you. It's my coach here. So, with that in mind, I practice an art called Aikido. This is with my daughter, Kirsten. The name of Aikido is way to harmonize with energy. So working with energy. And the idea is to control the energy and not hurt the attacker. Okay? So working with this energy is a huge part of what I do in the hyper department and in engineering. Kirsten is a third-degree black belt and the third-degree black belt test is weapons. Working with weapons. And so what I'm going to try to do is work this into, because it's a big part of my life and it's a way I look philosophically at working with students, is harmonizing with energy instead of trying to destroy. Energy is neither created nor destroyed, right? You can transform it. And Aikido is all about transforming that energy from something that could be destructive and negative into something that is positive and helps the world. And that's the idea of engineering, is you want to help the world. What we're struggling with and what we're working towards are finding the tools that help you to do that. And so what my role is to search and find those tools that help us harmonize with nature so we can build a better world. And a lot of that philosophy and technique is built into Aikido. So I teach a PE class that you're all welcome to sign up for. Everybody can participate. It doesn't matter how old or young you are. I teach it in the hyper, so I have a dual role in engineering and in the hyper department. I've been there for about 20 years. When students said, why don't you take a course in the hyper department? So I went over and talked to the head of the department 25 years ago. And we set this up, so every spring and fall I teach Friday afternoons. I thought nobody would show up. Students do show up. So it's actually turned out to be quite interesting. And I learned about this when I went to Washington State. Judy, my wife, found the advertisement for self-defense for non-aggressive people, which I thought was silly, because I thought, self-defense for non-aggressive people. So I went to check it out and learned about Aikido, opening up again. And this opened up my eyes to energy. This is energy. As an engineer, we study energy all the time, but this is hands-on energy. And so the idea is to blend these two together. How's that? So what I found here is a student who is one of my Aikido students, Pascal Watson. Come on up. Going to do a little demonstration here. I'm not going to hurt him, and I'm not going to hurt you. And this is Pascal Watson. How about that? Let's see, Pascal, tell him what your major is.
I'm a horticulture major.
And what year are you?
I don't know anymore.
Okay, that's all right. So here is your typical
Senior
student.
somewhere in
Lots of energy, lots of energy. So he's one of my Aikido students. So we're going to do something we call the unbendable arm. Unbendable arm. Where first I'm going to fight, and so he's just going to put one hand, and this is just right there. This is just a schoolyard game that kids would play. When I take first, I'm going to take a destructive. I'm not going to destroy him, but I'm not going to let him get a hold of me or beat me. I'm resisting like crazy. He is strong. We got a lot of youthful energy here, right? Keep going. You're doing good. So I'm going, hey, I might last for a little while, but I'm going to wear out. Okay. Now what I'm going to do is do the same thing, but this time I'm not going to fight. This time I'm going to do the same thing, but this time I'm going to relax. Go ahead. Because you know what? I'm not fighting him. I'm using his energy. Keep going. Who's wearing out here? Keep going.
I'm going.
You're doing good. You're doing good. So what I'm doing here is to harmonize with this energy. You're good. A little bit more.
A little bit more. Just a bit.
Yes. So as he does that, I should be able to walk around. Because you know what? It takes two to fight. Keep going. You're doing good.
Oh.
He's got a lot of energy. And so what I'm doing is teaming up with him. I'm not fighting with him. It takes two to fight, harmonizing with that energy. So I'm taking his energy and I'm just redirecting. I'm recycling or cycling this is harmonization. Okay. Pretty good. Thank you very much. Let's give him a hand. So this is what I'm doing with students over 40 years. I'm using the Aikido to take that energy and cycle it. And by doing that, I have all the energy of all the students I work with. Open up, channel the energy into something that doesn't hurt. So our kind of mantra, our philosophy in Aikido is don't hurt. Practice so that you can minimize any damage that's going to happen. So we work harder, not so we can do more damage, but so we can do less damage. So the deal then is if I take that practice, and I discovered Aikido, Judy came up with the idea, and I went to the class in 1975 when I was at Washington State, and I've been practicing Aikido ever since. Because I find that it's a great partner with engineering, because we're trying to look at how do we deal with the energy, in this case, energy and materials that we work with in engineering all the time. Okay? So with that kind of background, before the creation of EPA, the Environmental Protection Agency, we were in what has been classified as the linear economy, which means take it, extract it, make something, and then waste it, throw it away. That actually, in the industrialization, that was a way we built a lot of this country and the world. Take it out, extract it, make something, throw it away. This helped build an economy, okay? This helped actually build a better standard of living. So the idea here in our engineering approach has been industrialization is the unique way that the world has been able to increase the standard of living for the people in the world. okay? So that's one. So that's what we want to keep in mind. How we go about doing that is what we continue to develop and evolve. How do we do that? So our first crack at this for a long time is, hey, we want to take something and make it so we build the economy, build the standard of living, and then when we're done with it, we pitch it away. Okay, so that worked for a while. And then what we do is we get into the transition economy, which now with the creation of the Environmental Protection Agency in 1970 allowed us to treat the waste. Let's not just put it in a landfill or build a higher stack to dilute it into the, dilution's the solution to pollution, right? Yeah, so the idea then was transition. Let's treat the air, let's treat the water, let's treat the solid waste so we minimize the damage. So we try to get a hold on the damage, and we often said eliminate or minimize, and it was trying to minimize, but that was good because EPA, established by President Nixon in 1970, when EPA started, I was in Chapel Hill, which we'll talk about in graduate school, but they opened up the Research Triangle Park, and I was selected to represent Duke, Chapel Hill, and NC State to the opening of that EPA in Research Triangle Park, which had a profound impact on me. So the idea of taking care of the earth and trying to treat the waste is called a transition economy, and then that goes to treatment, and then you dispose of something, but as little as possible, okay? So idea is good. Now, today, we're looking at the circular economy. So this circular economy is the idea of resources cycle endlessly. I'm going to talk about a program I was involved with the United Nations and the State Department that actually had the biggest impact on what I'm doing and what I did in my career. The idea in 2002, I'm going to talk to you about what I was involved in 1972. But in 2002, it was put together in a book. Has anybody heard of Cradle to Cradle? Okay, so that's what I'm spinning off of. That was kind of a constellation. That book put together what I was working on from 72 with the United Nations and others. Cradle to Cradle is the idea where you're going to endlessly cycle materials. Like Pascal and that energy, I'm cycling that energy. So he's not getting hurt. I'm not getting hurt, but we can do stuff with this energy, right? So here we go, circular economy. Now we're putting this all together at the largest water reclamation facility. We no longer call them wastewater treatment plants. They are water reclamation. The idea is we're trying to reclaim, we're trying to cycle. We're not just treatment. So we're moving out of the treatment into the cycle. And this is the largest facility, 33rd South, Salt Lake City. This is where that $2.4 million project is focused for helping them to recycle nutrients. So the manager of this plant happened to get his PhD, and we just discovered this. He got his PhD at the same place that Judy and I got our masters. We met at Chapel Hill. And he's now running that plant, and he wants to look at the circular economy. So he actually contacted us and said, will you do that through what we had as a USTAR project? We went down and talked to him, and now we've got 20 students working on this project, which we'll talk more about later. There it is. It's 60 million gallons a day of water. It's the largest in the state of Utah, which is a great place to try to put this new technology that I'm going to talk about. So the idea is, how do we harmonize? How do we get the circular economy moving forward? Aspirational, but more than take, make, waste, and more than just treatment. So there I am, headed off to college. This is 1966, freshman, headed to University of Dayton, Ohio. And I'm a first-generation student. Nobody in my family, near or far, had any idea what college was about. So I assumed it was military school, and that was not bad. I mean, I'm okay. I really thought, well, I'm going to military school. So the high school counselor said, apply. Here's places to apply. So I applied and said, yeah, I guess I'm going to military school. So we're talking, nobody in the family, not relatives, uncles, aunts. I'm the first one that stepped into a college environment. So it blew me away. There's my neighborhood. There's where I grew up. So in 1948, I was born. There's Pittsburgh, Pennsylvania, in about 1948. You don't see much grass. You don't see much trees. There's a lot of shard metal. There's a lot of, look at the soil. The soil was pretty much shards of metal and broken glass. And that was where we played. That was the environment I grew up in. You acclimate, amazing, to your environment, and so this is all I knew. So we made what we could do with the the stuff at hand here. A lot of walks around. There's 4 generations. There's my sister when she's 8 years old. My mother went to 10th grade. My grandmother went to 3rd grade because this lady, the great-grandmother, had 16 kids. 4 sets of twins. Busy. So she had to take care of her because this is one of the 16 kids. And so not 3rd grade, 2nd grade, 10th grade, and then my sister actually did get her, she went to community college when she was 50 years old and got a 2-year degree. So look at the neighborhood. We're standing right outside where I lived in Pittsburgh, where we lived in Pittsburgh. This is a apartment, high-rise apartment. Look at Esso, Eastern State Standard Oil. Gas station right across the street. Fumes, yeah, but that's what you dealt with. Then right underneath them, the coal cellar opened up. We had coal delivered in 1954 to the coal cellar that we used for heating. Now, that way down the street a little bit was the Ohio River, and we were told never go near the Ohio River. You don't want to get anywhere near the Ohio River. So the idea, we were a little bit afraid of our environment, right? It was a little bit worrisome, but we dealt with it. So there's my dad. He went to 11th grade, joined the Navy because of World War II, went into the Navy. He finally got his GED, high school equivalent, when he was 56. Because his factory shut down, he worked in a casket factory. He was a coppersmith, so he was a really, really good person with his hands. But the copper, over years, 20 years, the copper absorbed into his skin. He wore a mask, so that every Sunday when we went to church, he ruined his shirt. We would go to church and it would sweat green. He would enter with a white shirt in 1955 and come back with a green shirt and throw it away. The doctors were amazed that human beings can absorb that much by skin absorption of copper. The algae don't like it; it'll kill those. But for people, he had green hair. He had green hair when he passed away, when he was 80 years old. So I'm bringing up to you the environment. How about this? That I grew up in and dealt with. In 1948, the year I was born, 20 miles from Pittsburgh to Nora, Pennsylvania, had the worst bog in the United States. 20 people died. So Pittsburgh, right, steel capital of the world. And when you're in the 50s, right after World War II, lots of smoke and lots of coal. So how many of you seen October Sky? Okay, good. So that was my group. That was my crew. Running around, setting off rockets, coal mines, West Virginia, and the steel mills. Okay. Most of my dad's friends got hurt working in the steel mill. Luckily, he worked in a casket factory. So he did the copper. And my mother and grandmother did the linings in the caskets. So the whole family was associated with National Casket. And they made the caskets at $25,000 a casket for the senators and congressmen. It's called National Casket. They went out of business in the 1960s, 70s, and he was out of a job. And that's when he went into printing presses and worked there. So there, in 1969, I'm 21 years old. The Cuyahoga River catches on fire. So we have some water issues, and that's close. Cincinnati, close enough to Pittsburgh. So environmental issues, the linear economy, right? This is a product of the linear economy. We're still growing, we're still building machines, and then Rachel Carson comes out in 1962 on Silent Spring that talked about DDT. DDT was really good for malaria. It was super good to help our troops in World War II. But the side effects that they never realized was that DDT would get into, it's persistent in the environment. It's chlorinated. It gets into eggshells of birds, and then the eggshells break and the birds don't live. So the whole thesis of the book is we have to be aware of these effects. When we build this insecticide that's good for human health, we are really upsetting the environment. The book was a huge success. In fact, because of this book, the EPA was formed because of this book. That was one. The other one we'll talk about is Earth Day. It's coming up. So that made a big impact on me. These pesticides are not good. Growing up, learning about this, and then we have Earth Day. I was 21 years old, University of Dayton, when they had the first Earth Day. 10% of the population of the country participated in Earth Day. Celebration. So I was very interested with all of this stuff going on in the environment. So I ripped off, one of these pieces of paper on a bulletin board to apply to Chapel Hill, North Carolina School of Public Health. And that's where I ended up going. But Earth Day was a huge wake-up call. And see, this is April 21, 1970. In December, EPA was instituted, was established. So between Rachel Carson and first Earth Day. Now, what is it next week? When is the next Earth Day? April 22nd, and it will be the 52nd. So invest in the planet is the theme for the next Earth Day. So all of you, just a heads up. Another opportunity. So now, University of Dayton. So I went there, like I said, just they said apply. I went, showed up at the University of Dayton, and 66 started, 1966. So I started as a physics major. So I took these, you take these tests in high school, and I scored really well in physics. So I started out at Dayton as a major in physics and a minor, in physical education. Sounded interesting. Then what happened is I'm interested in physics. 1968, the book, The Double Helix. And that changed my career there. So I read that book. I ate the book. I read the book. I was really interested in physics, of course, space, Star Wars. So I was going into physics, and then the double helix came out, and it just blew me away. The idea of DNA and the double helix and that story, and so I switched majors and went into biology because it was now, hey, we can do fundamental research. So I took genetics. You can imagine genetics in 1969. Not a lot, but we knew about DNA, right? So that changed the course of my career, was the double helix. And then undergraduate research. So somebody in the back said, Ron, this was kind of the early days of vaping. So early days of vaping. So what did we do? So I wanted to get involved in undergrad research. So the professor who had a National Institute of Health's grant, said, how many of you want to get involved in a experiment with me? And of course I want to do that. And so we sat in that car, 5 of us, and we breathed carbon monoxide for 2 hours every Saturday for 2 months. Yeah. What you do when you're 21? Yeah. So the idea, early days of vaping was brought up, and that's kind of what I was doing. And the guy who made up the CO, he was a chem major, so he made it right over the chassis. And what happened? Those are the days. You wound up the window, and then you had the locks. Well, our teacher locked us in, wound up the windows. He would come by every 30 minutes. He would come by. You know what he would do? Knock on the window. We're okay. We're good. Every 30 minutes. They would give us a hematocrit test, and they'd give us one of these whack-a-mole before we went in the car. Then we sat in the car. The chemist who made it up, actually fainted one time because he was sitting right over the CO generator. He fainted. We were knocking on the window and saying, we got to get out here. And the teacher came by. We got him out. We got him regenerated again. But what happened? So undergrads interested in this was for free. I didn't even get paid doing this. I just wanted to get involved in undergrad research. And here was the refereed publication that's produced from that. And it says, the time course of hematological response to experimental exposure to carbon dioxide. Jim Ramsey was one of my heroes because he let me participate in this. And what happened, it says, in that report is elevation in hemoglobin and hematocrit may continue for 2 months after you stop. So we kept being measured every weekend. And after 2 months, it was still above background where we started. So getting involved in undergraduate research is good. Just today, we're a little bit more cautious of what we do. And I use this in my capstone design class to show that ethics do change over time. When students go, no, ethics are, no, they're not immutable. Look at this. So I use this as an example, that ethics do improve. We are in a better situation today. Can you imagine getting permission to? You couldn't. You just couldn't do it. Anyways, that's my pitch to undergraduate. They're a lot safer. They get paid today. Getting involved. Then Chapel Hill. So finished there, Earth Day. And the guy who wrote me a letter to Chapel Hill is Dr. James McMahon. How many people knew Dr. McMahon? Okay, he was my hero. He ran around campus at Dayton giving these talks on the Vietnam War and how it was creating these basically insects, et cetera, et cetera. But anyways, he wrote me, I took his course, which was an ecology course, and that also inspired me to go to Chapel Hill. And so he wrote me a letter of recommendation to Chapel Hill. Judy, I met there. So that lady, I was 1 year ahead of her, and she came 1 year, and I was a student rep. I was the student representative. It was the Department of Environmental Sciences and Engineering. And so I was really active and said, yeah, I want to get involved in this. So I got to write letters to all the students coming in, and I wrote a letter, and that was one of the letters, and said, come on in, we'll get to know each other. How's that? She was working for Dr. Fred Fender, who just came out of Cornell, on physohex, which, notice all the chlorines on there, just like DDT, means that this stuff bioaccumulates. So her project, I would run around with her, and we would go to these downstream areas from hospitals where they use physohex like crazy. It's a skin, disinfectant. But they use so much in the hospital, it got into the effluent from the hospital, and then it would bioaccumulate in organisms. And it was starting to show that it was showing up in milk and other, just like DDT. So they outlawed it in 1972, but her master's was spent on bioaccumulation of physohex. What that meant for me, in a way, is, hey, I get to go out and go to the country. I get to see trees. The water might be really contaminated, but this is better than the environment that it was in Pittsburgh. So now, the trickling filter. This is actually from Central Valley, but picture a similar one at Chapel Hill, and picture a poor student, graduate student, who is going on a date. So what he does is he buys an ice cream cone and says, hey, come and see my project. So out at the treatment plant, they had these trickling filters. Those arms rotate, and the wastewater goes over some plastic, and the organisms grow and treat it. But I would take her there. We actually got on the arms, which you're not supposed to do, but it was a cheap date. That I could afford. How about that? So we dated through when I was doing my master's at Chapel Hill, and the master's at Chapel Hill was actually working with phosphorus to prevent eutrophication. But in those days, in 1970 to 72, we added chemicals to precipitate the phosphate, lock it up, put it in a landfill. That was treatment. That was better than make, take, and throw away, waste. But now we're at least doing something. But what I was involved with is using lime and ferric chloride chemicals to pull that stuff out so we could get it out of the water. Okay. Now here's something real quick. So they would get filter flies. It's North Carolina, right? It's warm. So you get filter flies and stuff growing, and they would clog up the pores. And so here's what we did. Ethics in those days. What the plant manager would do there is he would pour gasoline. He would fill it up so that it flooded, pour a little bit of gas. You need a little bit of gasoline. And that would shut off the oxygen, so it would starve the organisms, and they would die. Then you know what we did? We turned on the trickling filters and washed it all down. Some of it got caught in the clarifiers, but some of it went into the stream. But you know what? We had these things working again. But we were at least treating. We were trying to treat. So eutrophication, back in 1970-72, Chapel Hill had a big project doing that. And I worked at the treatment plant for the city. So transition economy, huh? And then we go to ice cream. And then we go 40 years later, this is out of Bryce Canyon. So as mentioned, Judy is in charge of the on-site wastewater treatment training center for the whole state of Utah. And she did her master's. She's got 2 masters also. So we really got into the education game, appreciation of the education game. So there we are in Bryce Canyon, 40-some years later. We're coming up on 50th anniversary coming up next year. How about that, huh? Yeah. Adventures, more adventures, right? These are adventures. So what happened to Chapel Hill? Graduated from there, and what happened? They had a faculty member who was an assistant professor, and he was supposed to be in charge of this project. Chapel Hill, like the BIE department, had a huge international program. So there was a program that got funded from the United States State Department, the Agency for International Development, and the United Nations Industrial Development Organization. Big project. Lots of people I'll talk about in a second here. And they told this new faculty member, you can't do this administration. You need to write proposals and get publications. So the head of the department said no. But I had known the head of the department since I was the student rep, so he calls me in at 23 and said, would you like to be the director of this program? I had no idea what I was getting. It was totally over my head. I didn't know what the heck was going on. But I was waiting for her to graduate. So waiting for Judy to graduate, I said, sure, why not? So anyways, the adventure there was, this was the international program in environmental aspects of industrial development. That's the same thing I'm talking about today. How's that? This is 1971, 72, 72. So this is me. There I am. How's that for a 70s picture, right? There I am. Fits, right? Fits. Yeah, you can't make this stuff up. This is 1972. So, and those are my bosses. So Daniel Oken was the head of the department. He'd come down from Harvard, and he, one time I found his dissertation in a desk, rummaging around, because I was always there in the building. But I found it, and he got his PhD when I was born, 1948. He got it on wastewater treatment and oxygen. And Arthur Stern was called the father of air pollution. He wrote 20 volumes on air and air management in those days. So he was recruited by Chapel Hill. Those are my two bosses. We had 29 participants from 17 countries, all senior decision makers in their countries. So here I am, 24, and I'm the director. So what I had to do is go out every time they landed at the Chapel Hill Raleigh-Durham airport. I had to be the one to welcome them. So I'm 24, 25, and I go out and say, "Hi, I'm your director," and they look at me, and they go, "Where's your boss?" So I take them back to those two guys and say, "Hey, Dr. Oken and Art Stern, Professor Stern, how about you dealing with them?" But this is what set me on the trajectory I'm on today, because I got to work with these people from all over the world. And my job was to set up factory interviews. I had to call 25 different industries. My assignment was, Ron, get these 25 industry interviews set up, and then you're actually going to organize taking them there around the Southeast. We're going to go visit these industries and see what they're doing for environmental health and industrial development. And part of this whole project was, this is 1972. This is EPA's just born. And the idea here was what we're doing in the circular economy. Let's look at how we can have industry and have a safe environment and protect public health. That was 1972. So at that time, I'm just trying to survive, to make this thing work. And I learned so much from traveling with these senior industrialists. It was a super, I was always at Washington, at the State Department or at the United Nations, because I was the gopher. Okay, go up there. And I'd go visit with the United Nations State Department when they had, here's an update, here's what we want you to do. It was when you're in Chapel Hill, it's called it was really the bus. It was a plane, but you get on in the morning, you're up in DC in an hour, and then you run around all day and then come back. So it's right there. So they actually called it take the bus up, which meant the plane. So I spent a lot of time in the State Department and in the United Nations in New York. We actually graduated everybody in New York. But to me, this was global. So you had EPA, AID, United Nations, Industrial Development, all coming together. Those are some of the 25 industries that we visited. They included heavy industry, steel. They included light industry, food. They included electronics. Okay, we went to nuclear power plants, all kinds of stuff. Then I finished that, and the department head said, "I'm taking that, thank you very much. I'm going to take that over because you need to go back and get some more technical experience." He was right. So he said, "Now go get another job." So one of my advisors on my committee said, "Hey, they're looking for a laboratory supervisor at Bayer, the German company, in Charleston, South Carolina." So the guy who was my advisor had actually designed their treatment system and said, "Go ahead and apply." And I look and I go, "It's 5 years experience. Are you kidding?" He said, "Well, if you don't apply, you're not going to get it. So apply." So I did, and I got it. So I became the director of their environmental control laboratory. This is protecting the Charleston estuary. So the deal here is fish, environment, and what are we making there? We're making textiles. We're making pharmaceuticals. So the state really came down, it was high scrutiny, and so I was in charge of training all the technicians on how to do wastewater characterization. So I would go home at night, Judy knows that, read, study like crazy. Like, God, I got to teach them how to do something tomorrow. Then the next day go in and teach, and then the next day learn something else. But it was another one of those experiences that was very difficult. We interviewed at 2 different jobs, Judy and I, up in New York, but I took the harder job. So this was, man, if we go work with Bayer, this is going to be the hardest job. And the other one in New York was sampling in a boat. It was nice, it was friendly, but it wasn't going to be as challenging. And so what do? So Scott Hinton, who was my boss, calls me a risk taker. And so way back then, I said, yeah, I want the harder job because I want to learn. Again, looking at all the energy. So transition economy, treating the wastewater, textiles, and pharmaceuticals with biological processes, treating them with physical chemical processes, pilot plants, because they were going to scale up. Then I learned about the internal disagreements within an organization where my boss was a chemist, but there was also an engineer in charge. They didn't get along, so I ended up playing that role. And in the iPaid program, whenever I was hired by Dan Oken and Arthur Stern, they said, "Now look, the woman you're going to work with to support the program wanted your job. She thinks she should have your job. So you know what? Your responsibility is to make it work, to get along." So another one of those, like, well, we're going to learn a lot here, okay? So Chapel Hill, Then from Chapel Hill, when I finished that, the idea was now I could study the biology, the chemistry, and I learned something, but I needed to get a master's degree. So I went to Washington State. So that was our chance to explore the West. Let's go to Washington State. Judy had applied there and had gone to Chapel Hill. So we went out to Washington State, and I worked at the largest steelhead fish hatchery in the world. This is huge. And what they were trying to do is recycle the water to increase the temperature a little bit to make more productive the steelhead trout, because that dam has more concrete in it than the one Las Vegas, around there. So fish ladders, 2-mile-long fish ladders they would need, not going to work. Because you know what? As the fish would start up, the birds would pick them up. So they decided to, actually what they did is they tried a recycle system to grow those. And what happened is they learned, I was dealing with the nitrogen because it's toxic, the ammonia. But the toxic ammonia, I was working on trying to get that down using ion exchange. What they found, what the fish biologists found, if you put a little more magnesium and sodium and potassium and calcium, the organisms are able to withstand higher concentration of ammonia. Like, wow, that's really cool. So what they do is they put more salt in the water. The trick is they let the fish out. They thought they were in the ocean. They didn't go anywhere. So go downstream, go downstream. No, so they had to put them in a truck. Took them downstream. And then, they can't get up over the ladder, so they had to put them in a truck and bring them up. So the joke at the fish hatchery was, but these fish, as they're evolving, they can't swim. They're not going to swim. So anyways, I worked on that for a couple of years. Here they are in the fish raceways. And what they did there is the engineers, so civil engineers and fisheries, this was great. They came up with a better system. Instead of hiring 30 people to hand feed, they set up a blower system that could count the fish electronically in those and then weigh out the food and blow the food through a pipe into these. Great idea. This was really good. This is teaming up biology and engineers. What they found out when they turned on the pipe is the end of that pipe, all the fish, in water you can hear much better. So all the fish raced down to the opening, and then they all pushed against the side of the concrete tanks, and they all got ick, disease. So they went back in the end and said, well, this was a nice experiment. Didn't work. They went back to hand feeding. So that's transition economy. How about that? Research Triangle Institute. Then I decided, I got called up. We were in the crisis, energy crisis. And so I ended up going back, getting a job at Research Triangle Institute because they liked the masters, the two masters. There's one in science and one in engineering, because I'm trying to put this thing together. Transition economy, working on hazardous waste. This was coal gasification. We tried to take coal, southeast, dirty coal, combust it, clean up the gas. Good, we get gas. But what we ended up making is a huge amount of contaminated water with the carcinogen in it. So what are you going to do with the water, right? So I got involved in that for my PhD at North Carolina State, where I actually found a chemical engineer who was interested in hazardous waste. So I ended up, this was a minor, I ended up minoring in math because he required that. I minored in toxicology and soil science. So I told him I need to spend one more year. He said, Ron, you can get out of here in 2 years. You got 2 masters. And I said, no, give me 1 more year, because this is going to be the end. I'm not going to be able to get more. So I stayed for 1 more year to work on that. And then when I graduated from there, we were looking for a place to come. And Joe Middlebrooks was the dean out here long ago. He was world famous environmental engineer. So we applied to Utah State, and we both came out here in 1982. Judy and I both came out. And what we did is picked up on this idea of industry. This is looking at the town of Libya, Montana, had a wood preservative site, contaminated the soil, went in, contaminated the groundwater, shut down the whole water supply for the whole town. So they said, can you do, meaning EPA and others, can you do something with the soil? So we got involved in bioremediation, which was a way to try to assimilate. Now we're moving to assimilation, cycling. We're starting to get into the cyclic, circular economy. These chicken wire, as the chem engineers call them, chicken wire chemicals are carcinogenic. They're in the wood preservative waste, they're in petroleum waste. And what happens is right here in these areas where you have what they call a bay region, that's where that interacts with the DNA and causes mutations and causes cancer. And smokers are great. In fact, when I was in Carolina for my PhD, I went to Liggett Myers, went to the smoking places to get their processes for chemical fractionation for the hazardous waste I was working with. So out of this, we discovered 3 microorganisms in the soil that could degrade these carcinogens. And Dr. Miller was the one who actually helped me do the microbiology to identify them. And because of that, he said, I got to name them. I got to name the organisms. So I got to name one after Judy, JLS. So this is mycobacteria. They cause tuberculosis, but these are environmental, so they're not that bad. They're friendly. They're good. They degrade. These are your friendly bugs. Yeah, so I have to preface that. So one was JLS for Judith Larrabee Sims. We found another one for Kirsten Marie Sims, my daughter. And then we found a third one for Matthew Charles Sims. So we now have 3 strains named after my family. We never found the 4th one for me. We're still looking. But we got those 3 in the refereed literature, and what we were able to do is have them remediate the soil, then take that remediated soil, plow it into contaminated soil so we could bioremediate, starting the cellular economy. There's KMS. So these are published in the refereed literature. We had to then, doing the science, we were able to write the EPA guidance manual on land treatment of hazardous waste. And the science behind that was to show that these chemicals actually degrade. They are metabolized. They don't just disappear into the groundwater, or they don't disappear into the atmosphere, because a lot of it was they disappeared in the soil, but where did they go? So we had to show that they actually are degraded to more simple chemicals. And in those days, in the 70s and 80s, you could say, that's harmless. They degrade to water and CO2. You can't say that anymore. But that was my big, hey, it just goes to CO2, so what's the heck? No longer, you can't do that. So here's synchrotron. We went to Lawrence Berkeley National Laboratory, used their synchrotron to show this is a decrease in that pyrene in if you add humic material from soil, just ordinary organic material, it solubilizes the pH compounds, makes them bioavailable. If you don't add humic material, they last forever, 160 some hours. So the deal here was circular economy, use natural humic materials from soil, and that's actually better than applying chemicals. So there's some of the science, and there's the real people behind the bugs. So here's Judy, here's daughter Kirsten, son Matthew, and then here's the new additions. Kirsten has 2 daughters, so we have to find 2 more bugs. This is Elena and Gabby. So that's the people behind the organism. So the search never ends, right? So here, we're developing resource-appropriate solutions we're talking about now in the circular economy. And I served on the Governor's Water Quality Board for 10 years, and the idea was to help communities to install wastewater treatment, now reclamation plants. We were able to help communities all over Utah. It gave me a good way to get to know the different parts of the state. And that was a real pleasure to serve with Governor Michael Levitt. There was about 10, 11 of us on the board, but I represented the academic side. And then we get the 2020 and 2022 on both sides of me, Greg Madden. So he had to come up with resource appropriate with a public school cafeteria budget, coming up with a way to improve eating habits. How about that for constraints on that problem? And then, as was mentioned, Dr. Melanie Dominich Rodriguez in 2022 does interventions, mental health interventions, and she's working on culturally appropriate mental health interventions. Very difficult thing, so that's some of the constraints there. This is the wastewater treatment plant at Central Valley, and so what I'm just going to do is 60 million gallons come in a day and 60 million go out, and I'm going to take you to this digester where they make gas. So they convert basically the chemicals in the water into microbes. They put the microbes into a big anaerobic tank and they make methane. In that methane, they run half the power in the plant. So it's really good. Then the solids that come out, when they get the solids out, they make compost. What's left? The water. So the water that is in this tank is 0.6, 600,000 gallons a day. And that water is highly, not polluted, it's highly enriched. Working with industry, they taught me, Ron, it's not polluted, it's enriched. Electric Power Research Institute, Ron, it's not polluted. When you talk, it's enriched. So, but they're right. I mean, it's the way you look at it, right? It's the way you're going to handle that energy. So these are highly enriched with nitrogen and phosphorus where we can grow algae, which I'll talk about in a minute. What happens is that's an Olympic-sized pool every day of water. So you're running through an Olympic-sized pool, and what do they do with it now? Since they can't do anything with it, they just put it back in the front of the plant. Dilution's the solution to pollution. So that management said, we want to do something with that water. It's energy rich. It's a resource out of place. So that's what we're using to grow algae at this plant. So here's an assignment. You can look at this assignment when capstone design. All right, assignment. Students, identify and study how ecosystems endlessly cycle energy and materials. All right. Now, here's what you have to come up with. You design a system that sequesters carbon. Once you do that, it has to recycle nitrogen and phosphorus. It has to accrue solar energy. I want it to purify water. It should make oxygen. It should make complex sugars that we can use for other types of applications. And it needs to self-replicate. Bioeconomy is essential because we're industrializing. How's that for an assignment? Ouch. So, and then I'm going to give you another assignment on top of that and say, now I want you, as an engineer, now design, optimize, and scale that up. Integrating what you did with the bioeconomy. Let's scale it up. Let's industrialize this stuff. So we want to produce sustainable bioenergy and sustainable bioproducts. We want to cycle them in the circular economy. We also want to protect human health and the environment. We've learned a lot historically, and we don't want to backtrack. So what are we doing? Algae. Okay, algae. Yeah. The idea here is this is algae growing on a biofilm. Parker Goldsberry, one of the graduate students on the project. This is growing algae, and the way we do that is that water, that 600,000 gallons of water that comes out of the anaerobic digester, we're using that to feed the algae on this belt. We move the belt through, so when the belt comes up, it's exposed to the sun. Now we're using sunlight to grow more algae. When it's in the water, it's picking up the nutrients. So what we found out then, the idea here is discovered in the previous student, and that's why we're relaying it forward. The idea is when it takes its time going up and down, it's exposed to the atmosphere, and in the atmosphere, the water evaporates. And when the water evaporates, it concentrates the salts in this system, and we get the production of something I'll talk about, struvite. And also we have, I'll chat about this in just a moment, where we're going. So we put this all together, and this is the project we're working on. These are our industry partners. West Tech, Salt Lake City, headquarters, international. They make water and wastewater, and they're actually making our pilot plant down there. So they're the manufacturers. Pacific Northwest in Richland, Washington is working with us on genetics. Central Valley Water Reclamation Facility, I've talked about, and Algix makes shoes, bioproducts. So we do this in the laboratory. We're getting into the circular economy. What are we going to do with this stuff? So we're taking up the nutrients, and then we're using the algae to make bio-oil as a substitute for petroleum oil. All right. So that's the oil we make, algae oil, and Jacob Watkins in the back there is involved in this project, and we'll chat about, we can make biodiesel. So he's also going to be involved. They're interested in biodiesel. See, local. Every community has a wastewater treatment plant, right? So we have local resources. So the idea is every community can do this, and so you're starting to decentralizing, and you're starting to have communities own what they do. They own their technologies, and then it's locally energy independent, right? Is the idea. There's the shoes. So Algix will take our algae, and they'll make shoes, and you can all order your pair of shoes. We'll let you know whenever we give them the algae, and we'll give you an order for them. Those shoes can be put in a landfill. So they're made out of algae, and they're biodegradable. So we're going to work with them. And then what we found out by accident, scaling up, when we scaled up, we found this crystal that formed that ends up being struvite, magnesium, ammonium phosphate, 1 molar each. The plant manager's looking at me, and we're watching this down there at the pilot plant, and he goes, Ron, look at those white specks. That's struvite. Struvite is the enemy of anaerobic digesters, because what it does is it precipitates in pipes and pumps and screws everything up, and they have to get in and pull it out. So they have a problem with struvite, and now they remove struvite by pushing air through the water, tons of it, very expensive, to increase the pH. Drive off the CO2, increase the pH, precipitate. It works, but it costs a fortune. Here we have algae. What do algae do? They raise the pH. They take CO2 out of the water. So it's a byproduct where they're taking the CO2 out as part of their photosynthetic reactions, and then we have it exposed to the atmosphere, so we're getting evaporation. And then the algae itself is providing nucleation sites. So he says this is the first, we published this just a couple months ago, this is the first evidence of biologically induced struvite production ever observed. And if this happens, then they can take away that expensive process of using all that energy to push CO2 out of the water, which goes back to the circular economy challenge. Then Jaden Storer's working this, and also Jacob Watkins, our 10-liter upscale that you'll see next week, next Wednesday. We're opening up the algae processing and products facility. You're all invited there. That's at 4 o'clock. Next week, come on down and see some of this stuff. What they're doing there is he's taking that gas here. How about that for big methane containers? That's how they run half the power in their plant. There's the student, Jaden Storer, and he's taking this methane and feeding it back to this reactor and making ectoin, which is a osmoprotectant cosmetic. How about that? And that same device, we have 2 of them. Jacob Watkins is interested in cellular agriculture. We don't have to take cows to Mars. if we take cellular meat, cellular agriculture? New idea. So we've contacted Upside Foods, synthetic meat, and they're all excited about looking at this. And then maybe Elon Musk is the next phone call. We have something for you. So we're going to look at cellular agriculture and treating waste. And so we're back to that. This is the teacup. What I show here, mass transfer. It's easy to stir. You put sugar in, you stir it up, and it's just reaction limited. Now, try that. So when you've got 600,000 gallons a day, scale up issues. And that's where the engineers learn about scale up, and that's one reason I went back to get a master's in engineering. This is thanks to Utah State, particularly thanks to Scott Hinton, Dave Cowley, my dean, and the blessing of Lisa. This is our new scale-up facility that goes from the laboratory. You'll see next week when you show up. From the laboratory, before we hit the industry, we can bring industry here and say, hey, look at this. We can scale this up. We have 20 students working at that building, and they'll be there next Wednesday to show you their projects. So that's what's inside the building. We can scale up and have 100-liter bioreactors. Those are 27 cubic feet apiece. Large industrial ovens that we can dry the algae and work it through. And we'll have these rabbers at the the Algae Processing and Products Facility. There's a video. Look at it. See how slowly it runs? So that means you don't need much energy. So we get two benefits. Cut back the energy, and then also it evaporates, so you get more struvite. So we're saving on energy and producing a product at the same time. See how we're working the circular economy? Always looking at it in terms of energy and harmonization. Energy and harmonize. How do we harmonize the engineering? And there's the big one, scale up, they're working on right now. That's 1,200-gallon tank. The other one you saw was a 100-gallon tank. That's 4 feet wide and 44 feet long, front and back. But you know what? We're rechanging that. West Tech that's actually doing this is making another configuration right now that'll be the scale up. And this is what the DOE wants to see, is make large amounts. There's the pilot plant setup at Central Valley. These are clarifiers to remove the solids. That's what you just saw is the 100-gallon tank. And then this one will be where West Tech puts in a new embodiment with lots of cotton, lots of cotton belt, which is the best substrate to grow the algae. They love the cotton. So there are students, and they are sampling the trickling filter. The Central Valley has 60 million gallons a day, goes through trickling filters. They put these windows in. It goes all the way down through plastic sheets as the water purifies and bacteria grow. These windows, light, guess what? Nutrients and light, you get algae. So they just scrape the algae off the trickling filter and walk over and put it on that pilot plant that you saw about 200 feet away. So it's perfect. There's two students, Amanda Marovic and Jacob Watkins, and there's the algae that they're scraping right off of the trickling filter. So we can take it off, take it 200, 300 feet maybe, and put it on our pilot. So it's the same algae acclimated to the same wastewater, not quite as high a concentration, but they work. So there's one embodiment that we had before, which is DISC, supported by USTAR, and grew lots of algae on the disc. This is where we discovered struvite, the formation of struvite, and that's them putting the discs into the reactor. Again, scale up kind of challenges and issues. And here's Dylan Ellis, one of our graduate students, who's sampling and taking a sample of the algae off of those discs, and that's the algae we transform into these products. How's that? So scaling up, you've seen carpets and you've seen discs, so we're working on different embodiments of how we can do this. We had the Montana State crew come down and bring a $20,000 DO meter with them, and we actually took the algae biofilm and went down every 50 microns through the biofilm to look at dissolved oxygen, because we wanted to see how much oxygen the algae, remember one of those requirements makes oxygen, we wanted to see how much it produces. So what we've done now is Parker Goldsberry, we've ordered a $21,000 pH meter. Why are we doing this? We're going down through the biofilm to look at where the pH is the highest, because the algae take the pH up, they take CO2 out. So we're going to profile, because that'll tell us how tall our crop gets before we harvest it, right? So we want to make sure we harvest and get it, but we don't want to cut it out too much. So anyways, we're doing that, and then we got a call 3 months ago. This Water Environment Federation is the largest water reclamation organization in the United States, and they put out these things called Manual of Practice, MOP, and these are put out every 10 years. This one is, the manual is called Biofilm Reactors, about that thick. We were called up to put the first chapter ever on algal biofilms, the design. This will go to every consulting engineering firm in the United States. So we're getting the opportunity to take what the students are doing and what we're learning and put it into a chapter and have it published, the first ever, in a standard manual. And so what I'm bringing up here, the students do science and engineering. Science and engineering, science and apply. And that's kind of the lessons I've learned in my career is do the fundamental work and then write the application and then get it out there for the public to use. So this will be coming out in 2022. And the student back there, Ben, here's your hand. Ben Jones is actually a student in the math department. And we're working with his advisor so he can do math modeling of this system. And Dr. Richard Cutler has also been recruited by our team to help Jacob Watkins look at statistics. We need statistics. So those little ones, those little rabbits in the lab, we had 81 of them. So Dr. Cutler told us you need 81 in order to get some statistics. We want to look at light and temperature and harvesting frequency and hydraulic retention time. So Dr. Cutler, so this project is multidisciplinary as much as we can make it across campus. How about that? So we're happy about that. We'll get more. So we're finishing up here, folks. Waste is a resource out of place. How about that? Circular economy. Embracing industry is key. I'm a big industry advocate. We can do better. We can make industry work. It's not like we have to shut down industry. What we need is a better way to do it. And we're engineers, so we should be able to come up with, working with scientists, a better way to do things. Circular economy. Scale up, it says, is a relay, talking about all the students passing it forward. So what I do is take the energy of the students, pass it on to the next, and then I take that energy and use it for myself. Okay? So Aikido, right? Failing forward is essential. So I tell my students, fail. Just, tell me what you learned from that. Go fail, be honest. Fail forward is one of my favorite sayings for the students in the capstone design and graduate students. Trust in the drive to do good. Industry is not evil. Industry would like to do good. What we are trying to do is give them better tools so that they can be in the circular economy. Research is one of my favorite. I borrowed this or stole it from Carl Sagan. He says science, I put in research. Research is more than a body of knowledge. What the students are learning, not something they just write down and memorize and give back on a quiz. It's a way of thinking. And I put here a way of skeptically interrogating the universe. Ask questions. Students collaborate together. Come on up. Let's ask. Let's say it's not going to work, and then let's try to see if it'll work, make it work. But that's a big one because you can't just take a course, a 3-credit course, and memorize and take a quiz and say, hey, I got research. No. It has to be hands-on, mental on. It has to be done, and it takes time. Right, it takes time. So there are some students. This is Mr. Brad Hansen, who's the senior engineer at West Tech, who is in charge, working with other engineers to manufacture this rubber. And there are graduate students, left and right, here that worked on and continue to work on the project. And there is one of my students, Keith Albretson. See, I didn't do that to Pascal today. How's that? So he could take it. He's good enough to take it. The idea of harmonizing with energy. And so in an attack like that, in a throw like that, the attacker has to also be comfortable with dealing with energy. Otherwise, you're going to get hurt, right? So teaching people how to work with that. And I got a couple other of my students here also. So Kara Frischkorn you want to raise your hand? She got the outstanding student in mechanical engineering, MAE, last year. Yeah. So, and so Kara's also interested in the engineering and the kind of the engineering and Aikido, putting those together. And James, her friend next to her, engineer, also doing Aikido. So it's a good blend. Anyways, harmonize with energy now and take PE 1440. How about that? You can sign up, Introduction to Aikido. We're offering it in the fall semester. So before you forget, write it down so you can sign up for it in the fall, and would look forward to playing with you in Aikido. How's that? All right, folks, I'm done. Hope I kept you awake. There's food. Oh, I should give this back to you, and I'm going to mess this up, Lisa.
So I'm going to leave the question period to when we're having some refreshments so that you can approach Ron and ask him about all of the interesting topics he discussed today. So first of all, thank you all for attending today. Great seeing everyone. Tomorrow, Research Week continues with our final event, which is our Student Awards Ceremony we're very excited about. What we do is we recognize our student researchers of the year, and we also announce all of the winners from the Student Research Symposium, which concluded yesterday. And right now I can tell you there's massive calculating going on from our judges to determine who those winners are. And so please stop by at 11:30 tomorrow for that Student Awards ceremony here in the South Atrium. As you can see, there are refreshments available, so please stop and have some before you leave. And I encourage you to reach out and meet someone new in this audience and think about all the things that we were inspired by Dr. Sims today as you think about taking your own research forward. So thank you, and we look forward to seeing you tomorrow.